Hello, and welcome to Sonoran Desert 101. I'm Dan Gruber. Every steward should learn enough about the Sonoran Desert to be able to answer basic questions. This program summarizes information covered in more depth in other Conservancy educational offerings. It will provide a general framework for understanding our desert and some examples. The best way to get more familiar with the desert and the preserve is to take advantage of the Conservancy's many educational offerings. Everything we'll discuss today relates to the fact that this is a desert. We'll talk about how deserts form and the challenges they present to plants, animals, and people. So let's start by talking about deserts. When we think of an ecosystem, we usually think of the relationships between plants and animals. But the most basic relationship is between everything that lives in a place and the physical and chemical characteristics of that specific area. The latter present challenges and opportunities that all living things must utilize and overcome in order to be successful, which usually means to reproduce for multiple generations. So let's talk about the Sonoran Desert environment. What are some words that come to your mind when I ask you to describe a desert? Most people say things like hot, dry, barren, brown, no water or less than 10 inches of water. Our desert presents several key challenges. Deserts are characterized by aridity rather than just by limited rainfall. This means a high ratio of water loss due to evaporation and plant transpiration versus water gained from rainfall. In genuinely arid regions, the ratio of water lost to water gained usually exceeds 5 or 6 to 1, and in really dry areas it can exceed 100 to 1. The high levels of evaporation and transpiration are due to consistent low humidity, which in turn is the result of a steady influx of warm, dry air. Think about the implications of low humidity. It means there are few clouds, and therefore little rain. It also means there are few clouds, and therefore high levels of solar heating. The results are, first, limited water. To be useful to plants and animals, water must be at or near the surface, and the longer it's available there, the better. In the desert, most water runs off or evaporates quickly after the rain ends. Relatively little stays on the ground or soaks into the ground. Deserts also are characterized by extreme variability of water availability. Our rainfall is highly seasonal, with strong local summer monsoon storms and widespread, generally gentler winter rains. We can have very long, dry periods, punctured sometimes by flood events. Second, there's a challenge of high temperatures. We're located at a low latitude, so in the summer, the sun is high overhead. With few clouds, both the air and surface temperatures can reach dangerous levels. Although the same lack of clouds allows overnight cooling, very occasionally, towards freezing, the bigger challenge is the high daytime temperatures. These challenges, of course, are not unique to us here. In fact, climate change is making the entire globe, on average, hotter and drier, which means that more areas are becoming desert-like. We may think of Sahara sand dunes when we think of deserts, but in fact there are cold deserts like the Antarctic, coastal deserts, and semi-arid deserts. That's why there are deserts on every continent. Our Sonoran Desert is one of 4 North American deserts. We're joined by the Chihuahuan, the Mojave, and the Great Basin deserts. Here in Arizona, our low humidity is caused primarily by what's called the rain shadow effect. Moist air loses its moisture while passing over mountains. As moist air from the Pacific Ocean moves upward over the California coastal mountains, it cools, since air temperature decreases as elevation increases. But cool air cannot retain as much water vapor as warm air can, and so the moisture in the air condenses and drops precipitation on the western slope of the coastal mountains. The air goes over the top of the mountains and comes down the eastern side. It warms up as it falls in elevation, but it's dry by the time it reaches eastern California and all of Arizona, resulting in desert conditions. Since the prevailing winds at our latitude are westerly, blowing from the west, this effect provides a steady flow of warm, dry air. In other words, consistent low humidity. The Sonoran Desert covers just under 125,000 square miles. Most of it is a low, hot desert with an elevation ranging from below sea level to about 4,000 feet at the tops of the higher mountains. As many of you know, the distinguishing characteristic of the Sonoran Desert is having 2 rainy seasons. Now, all of the North American deserts get some summer rain, but we get more of our rain during the summer than any of the other North American deserts. Our summer storms come from the wet subtropics on southerly winds and produce localized heavy thunderstorms that provide, in a typical year, roughly 1/3 of our annual rainfall. Our winter storms come from the Pacific on westerly winds and produce gentler, more widespread, all-day rains. Yes, we have hot summers, but many plants and animals that live here today originated in the subtropics in what's today Mexico and Central America, and they've adapted successfully to high temperatures. However, because of the subtropical origin of much of our vegetation, it's not adapted to freezing temperatures. Having mild winters here, milder than any of the other North American deserts, allows the Sonoran Desert to host a wide variety of plants and animals. In other words, to have high biodiversity. It's interesting to see where the preserve is located in the Sonoran Desert. Scottsdale, shown in yellow, and the preserve, bright teal, are in the extreme northeast portion of the Sonoran Desert at relatively high elevations, ranging from about 1,500 feet in the southern preserve to 4,000 feet at the tops of the mountains. There's a significant rainfall and temperature gradient across the preserve. The higher elevations get a little more rain, and the northern portion of the preserve is further away from the Phoenix Heat Island, which also increases rainfall. Whereas downtown Phoenix averages about 8 inches of rain annually, parts of the preserve can average as much as 12 inches or so, a significant increase. Likewise, the higher and more northerly areas of the preserve also get cooler at night, due both to higher average elevation and also distance from the Phoenix Heat Island. Portions of the preserve occasionally freeze overnight, and, as some of you may know, can even get snow. Now I'll turn you over to Mike Nolan, who will talk about what's literally the foundation of our desert ecosystem.